Welcome back to Discovering Geometry with Mrs. Berry. This is lesson 24. Today we're going to talk about triangle inequalities. We'll have an investigation with side lengths, an investigation with angle and side relationships, and an investigation with exterior angles. First, let's talk about lengths. How long must each side of the drawbridge be so that the bridge spans the river when both sides come down? Well, they must at least touch so the cars don't fall in the river when they cross. They might even overlap some. What about the lengths of triangles? Imagine these blocks at the top in the lengths of triangles. Could we use the 4, the 3, the 4, and the 5? Well, it does look like they form a triangle. How about the 3, the 3, and the 6? Looks like we may have a gap there. I'm not sure that it would make a triangle. And the 3, the 3, and the 7, that one definitely won't come together to make a triangle. So let's investigate exactly what is needed. What is the shortest path from A to B? This is our first investigation. First, you're going to use the segments below to construct a triangle if you can. Which of these was possible and which one was not possible? Why do you think that they were possible or not possible? So here I'm measuring the lengths and then drawing a line in between. Then I'm going to measure with my compass again. And I'm going to just draw an arc. Anywhere on that arc could be the next vertex. If I draw the next one, I have another arc. And these form a teeny tiny triangle. So I was able to form a triangle with C, A, and T. Now I'm going to try it with patty paper. I just trace these segments and I'm going to try to connect them. And even as I close this one, I cannot get the H's to overlap. So I could not make a triangle with F, S, and H. Well, why is that? The shortest path from A to B would be a straight line. So the triangle inequality conjecture relates the lengths of the three sides of a triangle. Because the shortest path between 2 points is a straight line, then the path from A to C to B cannot be shorter than the path from A to B. So to put our triangle in there, the two smallest lengths have to be longer than the longest one, or else we wouldn't form a triangle. So the sum of the lengths of any two sides of a triangle has to be more than the length of the third side. So it has to be greater, or it's greater, or it's more than the length of the third side. Our investigation 2, where are the largest and smallest angles? So draw some different size scaling triangles, at least one acute and one obtuse. And then use your protractor and your ruler to label the angles. The biggest angle as angle L, the second greatest as angle M for the middle one, and then angle S for the smallest one. Then measure the three sides, label the longest side L, the middle side M, and the shortest side S. Which side is opposite of the angles? And why do you think that's so? So here's a video of how I use these two triangles. And I went ahead and measured them before the video starts. I'm going to label them. And I'm going to label the angles. And I'm going to look at how the smallest side is across from the smallest angle. And the largest side is across from the largest angle. That leaves the middle side to be across from the middle angle. Why do you think that is? If this angle is the largest, it's going to span out the biggest on either side, then it will make the longest side across from it. If this is a little angle, then it doesn't span out very wide at all, and it ends up making the shortest side across from it. So the side angle inequality conjecture. In a triangle, if one side is longer than another side, then the angle opposite the longer side is larger than the other sides. So the side opposite the largest angle is the longest side. The side opposite the smallest angle is the smallest side. So we haven't talked about exterior angles yet. We've only studied the angles inside the triangles. We call those interior angles. Triangles also have an exterior angle if we extend one side of a triangle past its vertex. So here's a triangle, and then we're extending this line out. And so that makes this exterior angle. Each exterior angle of a triangle has an adjacent interior angle. So the adjacent interior angle is the one that's going to make the 180 degrees. Okay, so those two will be supplementary. And then the other two interior angles, or the other two angles inside the triangle, are called the remote interior angles. Remote because they are further away from the exterior angle. So these are the two remote interior angles for this exterior angle. Of course, if we drew a line off of a different side of a triangle, we would have different remote interior angles. So the remote interior angles are the two that do not share a vertex with the exterior angle. So exterior and adjacent interior, and then the two remote angles. So our last investigation is going to be on the exterior angles of triangle. Draw at least two different scalene triangles, one acute and one obtuse. I went ahead and used the same triangles that I had in the last investigation. Extend AB beyond point B and label point D outside of the triangle on AC. Label the angles with lowercase letters matching the points at the vertex. Copy the two remote interior angles, angles A and C, onto patty paper next to each other so that you can add them together to show their sum. And then how does that sum compare with that exterior angle, angle X? Use your patty paper from the previous step to compare. So here's what you are going to draw, a triangle. You're going to extend this, and then X will be your exterior angle. You'll be measuring A and C and putting them together to see how that compares to X. Go ahead and repeat the investigation on your second triangle to see if it's the same. So here I am drawing my exterior angle, and then I'm going to go ahead and label them A, B, and C to match. I'm going to draw the angle on there. I went ahead and used a dotted line just to show its difference, and then I'm going to add C to it. So you notice I'm going to put one of the sides on the outside of the next one, and then I'll add to it. And it does overlap and match X. So here's my patty paper again. I'm going to draw angle A onto it. And then I'm going to put C right next to it. I'm going to match up this, one of the rays will be the same. And then I'm going to compare that to angle X. So I know this went a little bit fast, but hopefully you could see. Here we go. Whoop. Right there, that angle A and C together makes X. Now I was running out of patty paper, so that is a short ray, but it does match up to X. And then the same thing in the second triangle, A plus C does equal X. So the triangle exterior angle conjecture. The measure of an exterior angle of a triangle is equal to the sum of the measures of the remote interior angles. So A and C were remote interior angles to that angle X, exterior one. So that exterior was equal to the sum of the measures of the remote interior angles. Can you explain the reasoning behind why the triangle exterior angle conjecture is true? So think about 180 degrees is the entire triangle. And we said that the exterior angle plus so the sum of these angles is going to be 180. And this exterior one is going to be 180 degrees. Whoops, make this an A. With this angle B. So B plus X should be 180. And then A plus B plus C should be 180. So if we just rearrange this, we could say B plus A plus C equals 180. We can take the A and the C and replace it with the X. Because here, B plus X is 180 and B plus A and C is 180. So A plus C must be equal to X. Your homework will be having you look at these conjectures some more and using them in other problems. See you next time.